In this class, we see about the physical properties of carbohydrate, especially the glucose properties. In before classes, we study about the classification of carbohydrate and some important carbohydrates, biological importance of carbohydrates, etc. Here we see about the physical properties. Under this, so many properties present inside of glucose. First, we see about the asymmetric carbon. A carbon atom to which four different atoms or group of atoms are attached is said to be asymmetric. That means the center has C, that means a carbon, and around this the four different group of functional group or any other atoms present. So that is known as asymmetric carbon. Symmetry means equal division, asymmetry means unequal division. Already we know that. Okay. The next character is stereoisomerism. The presence of this asymmetric character of this carbohydrate give rise to formation of isomers of that compound. That means the stereoisomerism of that particular glucose and other carbohydrates have the anomeric carbon atom, that means the asymmetric carbon atom, so that can produce isomers. Isomer, what is isomers? Isomer means same molecular formula but a different structural formula or configuration. So in here, such compounds, that means the chiral carbon center bearing compounds which are identical in composition and differ only in spatial configuration are called stereoisomers. Two such isomers can produce by glucose. First one is D-glucose and L-glucose. The D-glucose is the mirror image of L-glucose. The L-glucose is the mirror image of D-glucose. Most of the monosaccharide occurring in mammals are D-sugars. Here is the image represented that the first image show that the stereoisomers of glucose, D-glucose and L-glucose, that is the mirror image of L-glucose is D-glucose, mirror image of D-glucose is L-glucose. So the OH position and the H position are changed in between this. So next we see about optical activity. The presence of asymmetric carbon atoms also confers optical activity on the compound. When a beam of plain polarized light is passed through a solution of sugar exhibiting optical activity, it will be rotated to right or left in accordance with type of compounds. That means the optical isomers are enantiomorphs. The optical isomers, also called enantiomorphs, when it is rotated to right, the compound is called dextrorotatory or put in a D sign. When rotated to left, the compound is called levorotatory. We denoted as the L, that means the levo. D means dextro. Then we see about the racemic. When equal amount of dextrorotatory and levorotatory isomers are present, the resulting mixture has no optical activity. So that is any more movement between them, since the activities of each isomer cancel each other. So there is no movement in between them. Such a mixture of solution is called racemic. That means in here both D and L a form of isomers are equal in nature. Then resolution, the separation of this optical isomers from a racemic mixture, and that means the equal proportion of L and D forms of isomers that are separated by the procedure. What is the resolution? Then we see about cyclic structures. Two reacting groups, aldehydes and alcoholic groups, present in carbohydrate. We know that aldehyde or keto of polyhydroxy alcohol is the definition of carbohydrate. Here, if the open chain form of D-glucose, which may be called as aldehydo D-glucose or aldose, it is also known as aldose because aldehyde group is present inside of glucose. This aldehyde group condense the aldehyde group on carbon 1 with alcoholic group on carbon 5. Two different form of glucose are formed. When the OH group extend to right, it is alpha D glucose, and it extend to left, it is beta D glucose. Here, there's there are two structures present in nature. There are the carbohydrates, especially the glucose, present as two structure or two states. One is linear in structure, next one is cyclic structure. The linear structure convert into cyclic structure when this type of reaction occur. This is the image of cyclic structures. The aldoglucose, that means the aldohexose, example of glucose. This glucose converted into beta D glucose and alpha D glucose when the bond formation between carbon 1 with carbon 5. Then we see about the mutarotation. It is defined as the when an aldohexose is dissolved in water, that means the aldohexose, example glucose. The solution is put in optical path so that plane polarized light is passed. The initial optical rotation shown by the sugar gradually changes until a constant fixed rotation. That means the first initial rotation is changed into gradually slow down the rotation, and a characteristic of the sugar is reached. This phenomenon of rotation is called as mutarotation. That means the interconversion of alpha and beta forms of D-glucose in equilibrium mixture. Next, we see about epimers and epimerization. Two sugars which differ from one another only in configuration around a single carbon atom are termed epimers. Glucose, galactose, mannose, these are fructose. These are same molecular formula but different structural formula, because any one of the carbon atom have the different positions. Glucose and galactose. Here is the example: glucose and galactose. Both have the same chemical formula, and that means the molecular formula, but the structural formula is different. The C4 of D-glucose contain first H and right side OH, left side H. Here D-galactose, the C4 position having hydroxyl in left side and hydrogen in right side. That is the different, and also this character is known as epimers. The process of this formation of epimers is called epimerization. Thank you all.